Hi, I'm Scotty. Welcome back to Scotty's Clock World.
This is the third video in the new bushing series that I'm doing. The first one, we used a version bushing machine. We rebushed each of the bushings that needed to be done in the strike side train. And then I used a reamer, one of those tools there, not that size, but one of those so you can see it clearly. That's the first wheel on the time side. I redid that bushing there and the one on the back. Now today for the third one, we're going to fix up these two bushings here, that one on the back there, that one on the front there, with the second wheel in it. Now the first thing you'll notice if we look at it is it's got a half crescent moon around that side, and also on the back side there, though you can't see it yet. Now somebody in their infinite wisdom has stuffed up the bushing that they had in that hole there, and they've used a hollow punch to move some material from here over to there to align the bushing properly to move it over. You can see how horribly loose the bushing is, and we're going to do that one now. Now before we start, I'll just say this method of cutting holes in a plate for putting bushings in is fraught with a lot of danger initially. It's something that you have to learn to do and not overdo.
It's very easy to cut a hole too big into a plate using a cutting broach. They are very, very efficient cutting machines.
They have 5 sharp sides on them, and each one of those takes a sliver of metal off every time you turn it round. So as you make one revolution, you're actually getting 5 cuts. It's a good idea if you haven't used a cutting broach before
To buy an old Lansonia or Seth Thomas or similar type clock. You can pick them up for about $20 in America.
and then practice on the plates, getting used to using a cutting broach so that you don't cut the hole too big. That's far preferable than starting off for your first attempt on a relatively good quality mechanical movement that you can make a mess of very, very quickly with one of these cutting broaches. Alright, that having been said, let's get into it. I'll remove the couple of screws that I've put in to hold the plates together so we could get an accurate assessment of just how bad the movement is of the pivot inside that bush. As usual, we'll start off with the bottom pivot down there. They've all been polished. We saw that before. So first thing we'll do, zero our vernier, and then we'll measure the diameter of the pivot, 1.22 mil. Put that in our foam block over there, and as always, jot down our measurement, 1.22 mil. Now over to our box of bushings, run along the top, see what we've got. 1.22, number 43 is 1.1, number 44 is 1.20, number 45 is 1.25. So we would reckon it would be a number 44. So I'll remove a number 44 bushing, being that one there, with the top back on the box. Now bushing on our hand and test to see if the pivot will fit in it or not. And it doesn't, which is what we expected. Alright, so we've got the right sized bushing. Now we collect the rest of the data that we need. It's a number 44. The external diameter of the hole is 3 millimeters. So we'll write that down. It's a number 44. And 3.0 millimeters. Right, that's all the data we need to be able to do this properly. Alright, once again, set up our vernier. We know that the maximum size of the hole is 3 millimeters, and we have to allow
3/100ths of a millimeter
for the hole to be sufficiently small for the friction to hold the bushing in place. So what we do, we start measuring our cutting broaches to find one that is approximately 2.73 for a final one. That's getting closer. And you'll notice there, it's not easy to see, but when you're taking the measurement, you've got to take the measurement from two sides, two of the cutting sides. Don't do it on the flats because your measurement will be too narrow. You must do it on the flats. That's 2.73. So we want to go up a tiny bit more than that, 3.01, 2.95. So that will be the maximum size that we want to be able to broach out this hole with a cutting broach. Now what we need to do is to find, that's 2.94. So what I would do there, keeping a tight grip where the measurement was. Now I'll put a little black mark on there. That means we'll be able to cut to there relatively easily. And then when we get to that black line, we'll be going very, very slowly. All right, this is the first cutting broach we need. We'll start opening the hole up once again, 90 degrees perpendicular to the plate. And we can afford to go relatively quickly on this as long as we maintain our 90 degrees, because we're a long way from the final hole size. And then across there. All right, I'll take that cutting broach out and we'll get the next size. Now what do we got? Yep, we can get a little bit on that. We'll put the cutting broach into the reamer, tighten it down, cutting broach into the hole, align it once again, 90 degrees, and start spinning it round. It's quite safe to go relatively quickly at the moment because that's the size broach we're using. That's the size we're going to finish up with. There's quite a significant difference there. We're going to go through 6 or 7 broaches to get there, I think. We'll have a look at the smallest one in the largest set. Yep, all right. We've moved now from the small set to the large set. Set it up in the pin vise, cutting broach back into the hole again and start cutting. You can see that the cutting broach is parallel to that post there that is also in serious need of some cleaning, so I'll run some steel wool over that before we put it back together.